Hello guys, now we have reached to the subtopic of 7.3 magnetic force on moving charge particle. So we have seen that a current carrying wire experiences a force when placed in a magnetic field. I do hope you have watched my two videos earlier. So please watch the two videos before you watch the section of 7.3 or else you won't understand. Now, since a current consists of moving charge particle, we might expect that freely moving charge particle would also experience a force when passing through field B. Okay, so the force of one particle, okay, is then F equals to Q modulus Q times V, the velocity of the moving charge particle, times B, the magnetic field. Remember, we are using the cross product. So whenever we see cross product, we will use sine theta. So the magnitude of the force experienced by a moving charge particle is F equals to the magnitude of the charge times the velocity of the charge times the magnetic field times sine theta. And theta, what is theta? Theta is the angle between the velocity, the direction of velocity, and also the direction of the magnetic field. So this is the theta. And the force is greatest when the particles moves perpendicular to B. Whenever the velocity is perpendicular, is 90 degrees to B, therefore sine theta will be equals to 1. And therefore, the force is the greatest when the angle between the the angle between the B and also the V is 90 degrees. Remember that. And the force is zero whenever the particle moves parallel to the B, whenever the direction of the B and also the velocity or the movement of the electron is the same direction with the magnetic field. Therefore, the force will be zero. No force will be produced. Remember this. Now, the direction of the force is perpendicular to both magnetic field B and the velocity of the particle V. Again, we will use the same right hand rules. Okay, let me change my pointer first. Okay, now remember, this is the right hand rule. You could always use this one, or you could use your thumb as the force. Okay, your index finger is the V, your middle finger is the B. Previously, we will use FIB. That is for current carrying wire. But for moving charge particle, we will use F, our thumb, V. The velocity of the moving charge particle is your index finger, and your B, the magnetic field, still will be your middle finger. Okay, right hand rule. So this is the second right hand rule. Sorry, the third. The first one, when we try to determine the direction of the magnetic field in a current carrying wire using your first right hand rule. Your first right hand rule, if you still remember, your first right hand rule is the thumb like this, and followed by all your fingers is curled up like this. It's curled like this. So this is your first right hand rule. Second right hand rule, similar to this, but we use FIB. The first right hand rule is for to determine the direction of magnetic field in the current carrying wire when the I is following the direction of your thumb, and the magnetic field will follow the direction of the curl of your fingers. This is B. And then second right hand rule is using FIB to determine the direction of F, I, also B, if any of the two parameters is given. And this is the third right hand rule. Use FVB to determine whether F or V or B of any moving charge particles. Okay, so we have three. right hand rule we have learned. So, but this direction only true for positive particle. Okay. The third right hand rule that I have shown to you, yang ni FVB ni, only for positive particle. If we are considering positively charged particle, use the third right hand rule. How about the negative particle? The negative particle, you switch to your left hand rule. Negative particle, use left hand rule. What is left hand rule? Just swap your right hand with your left hand using your thumb, using your index finger, using your middle finger, and then the rest of your two fingers, keep them inside. So the left hand rule, the thumb still force, the index finger still the velocity, and the middle finger still the magnetic field. So this is your first left hand rule, first and the only left hand rule that you have to use whenever you are trying to determine whether the force, the direction of the force, direction of the motion, the V, or the direction of the magnetic field. For the positively charged particle, use your left hand rule. Okay, so let's see this example. This example shows, I think this is for positive charged particle. Let's try. Okay, both. Now, this is positively charged particle. Okay, now it moves in that direction. Okay, it moves in this direction, meaning that this is the V. Okay, positive charged particle use right hand rule. And this is the B, that direction. Now, using your right hand rule, try to determine the F. Let's see whether the F is upward or downward. Okay, using your right hand rule. F we want to determine, we don't know. Your index finger is showing towards out of the page. What else? And the magnetic field is from left to right, and therefore your thumb should be showing upward direction. Your thumb. Okay, this is V. This is your index finger. This is B. This is your middle finger, and therefore you will get your thumb is showing upward direction. Remember, this one using right hand rule. How about the negatively charged? Use your left hand rule. Okay, so the direction of the velocity, this is your index finger of your left hand. Direction of magnetic field is still the same, from left to right. This is the direction of your middle finger. Okay, now align your left hand. Okay, you will get your thumb will be facing downward. So this is the F. Remember, this is for left hand rule for the negatively charged particle. Now, moving along. Let's see exercise 3. I won't discuss much about exercise 3 in this slide. I have made a recording of exercise 3. Look at my other videos in my playlist of chapter 8. Okay, look at the playlist of chapter 8. I made a video. Saya tunjuk terus never mind lah. Let us discuss. Terus discuss. Okay. Now determine the direction of B. Okay, direction of B. For each case in figure below, where F represents the maximum magnetic force. If F is maximum magnetic force, it means that the theta between V and between B, the theta equals to 90 degrees. Remember our formula, F equals to Q V B sine theta. And theta is the angle between the velocity and also the magnetic field. Whenever the F is maximum, it means that sine theta equals to 1. Whenever sine theta equals to 1, theta should be 90 degrees. It means that your middle finger and your index finger should be 90 degrees. You don't have to bend your middle and index finger at peculiar angle. Just make 90 degrees between them. That will be fine. Right. I'm not that insane to put any peculiar angle in any questions for the examination, yeah? Alright. On a positively charged particle, this is a clue. Whenever it is positively charged particle, make sure you use right hand rule. Right now. So this is the first case. So the F is the direction of F is out of the page. So your F will be your thumb. Your thumb is facing out of your face, out of the page. Using your right hand rule. Thumb pointing towards you. How about V? V is your index or middle finger. Yes. V is your index finger. Your index finger pointing to the left. So what is the direction of your B? Yes. Your B will be towards this one. Downward. Right hand rule, because positively charged particle. Now how about the second one? Now F is upward. Your F is your thumb. This is thumb. V is to the left. V is your index finger. Now, where is your middle finger? Yes, that one. Your middle finger should be pointing inside, towards, through the page. Okay, this is F, this is V. B is towards the page, inside the page. How about the third one? V. Your V inside the page. And V is your index finger. Your F is downward. This is your thumb. Align your hand. You'll get this one. F downward, V inside the page, and B to the right. What else? Oh, we still have one more exercise 4. Find the direction of the force. We need to find the force, direction of the force. And negative on a negative charge. It means that we will be using our left hand rule. Because negative charge, left hand rule. Oh, aku dah tulis. Okay, now V is your index finger. Going out from this page. Going out, So your index finger should be pointing on you. How about B? This B is your middle finger, downward. So where, align your hand, which direction your thumb is pointing? Like this. So this is V towards us. This is B, downward. F is to the left. Second one. B is going inside the page. V is downward. Remember what is B? What is B? What is B? Your middle finger. What is V? Your index finger. So where is your thumb? Align your hand. B, your middle finger towards the page. V is downward, your index finger. And therefore, your F is to the left. How about the third one? Getting easier, huh? V poking through the page. B to the right. What is V again? Your index finger. What is B again? Your middle finger. Your thumb, use left hand rule, you'll get this one. B to the left, V going inside the page, your thumb is upward. Simple as that. Exercise 4. Still we have exercise 4, D, E, F, but B upward. Make sure you know which rule you want to use, okay? This is middle, middle, sorry. This is index, and B is middle. Okay, this one also index, middle, sama, right? Where is your thumb? Okay, align your hand. This B, this is V, and this is F. All right. B is your middle finger. V is your index finger. F is your thumb. How about the second one? Now align your middle finger and the index finger 180 degrees. This is peculiar angle. Not 90 degrees, but 180 degrees. Your index finger, your middle finger. No F. There will be no F. See, the angle is 180 degrees. Therefore, sine 180 is 0. Therefore, no F. Right? Got it? How about the third one? Okay, B is walking out from the page towards us. B, here, B, your index finger, your middle finger. Your this is your middle finger. Your index finger is to the left. Okay. Of course tak perfect lah. Susah nak align tangan perfect kan. Therefore, your F is downward. Your F is your thumb. Simple as that. Example 4. The magnetic field exerts a force of 8 times 10 to the power of -40 Newton. Magnetic field. Okay. Toward the west on a proton moving vertically upward. So the proton, this is positively charged particle, moving upward. Okay, we have towards west. Okay, west. Now, whenever the angle is given in the in this direction, you should be able to sketch lah kan. Just remember the direction of the. Okay, this is north, this is south, this is east, this is west. Whenever they mention west, make sure it's towards your left. Speed is given. This is V. V is given upward 5 times 10 to the power of 6 meter per second. Determine the magnitude and direction of the magnetic field in this region. How do we determine magnetic field? Using the equation F equals to Q modulus VB. Sin theta, rearrange the equation, you'll get B equals to F divided by QV. How about sin theta? How about the angle between the V and also B? It is 90 degrees. Right? If it's not mentioned in the question, assume that they are 90 degrees. Now, we have the parameters. The force is given, the velocity is given, the charge of the positive charge particle is not given, but whenever a single positively charged particle is given, whenever the proton, okay, it is already mentioned, the proton has the charge of 1.6 times 10 to the power -19 coulomb. Proton is have similar charge with electron, but it is in positive magnitude. So we could calculate the magnetic field. It is 0.1 Tesla. How about direction? Using your right hand rule. So F is your thumb, V is your index. Where will your middle finger go? Thumbs to the left, index upward. Middle finger will be facing inward through the page, poking through the page, going inside the page. Example 7.3. Now, determine the magnitude and direction of the force on an electron. We need to find the force. Electron, negative charge particle. This use left hand rule. Traveling with such velocity horizontally to the east. To the east, remember. Which one is east? This one is east. This is west. This is south. This is north. To the east in a vertically upward magnetic field. Magnetic field is upward. This is B. Which way is the velocity of the electron? To the east. To the east. This is the velocity of the electron. And B is 0.45 Tesla. And V is given over here. So determine the magnitude and direction. Let us try to calculate the magnitude first. Okay. F max, meaning that theta equals to 90 degrees. Q, the charge of an electron. Remember the formula, we have modulus. Therefore, we take the magnitude only. The negative part of the negative charge we don't include in the equation. V is given. The magnetic field is given. So we'll get the F max is this one. How about direction? Using your left hand rule. B is your thumb. No. B is your middle finger. B is your middle finger. V is your index finger. So where is the direction of your thumb? Left hand rule. Middle finger upward. Velocity to the left. Therefore, your thumb is facing inward. Okay, using your left hand. So I've made a video for exercise 5. Please watch the video in the playlist. Yeah, playlist. We will discuss in this video. Please select the next video for exercise 5. That is all for 7.3. Thank you.